Alright, hello everyone. Welcome to my research project. My name is Colton Perry, and today I'll be talking about the analysis of the antimicrobial properties of Xanthohumol using both analytical and microbiological techniques. So, to give a quick introduction to Xanthohumol, it is a prenulated chalcone found mostly in the female hop cones. It's known for its many powerful anti-properties, as we can see in this image here below. My objective of this study was to determine the optimal extraction method to yield the most xanthohumol and to determine the full potential of the antimicrobial properties of xanthohumol along with its synergistic properties with an antibiotic. So moving into the methods of this study, the solvent extraction method can be seen here above. So I first placed all my hops in 100% ethyl acetate, filtered, transferred to the 3:1 ethyl acetate and water, and allowed for the liquid to liquid partitioning to take place, extracting the top phase off, and then roto-evaporating the ethyl acetate off the top phase, and resuspending in 100% methanol, running through mid-pressure chromatography, fractionating, pooling together my samples, filtering of course, and then identifying the samples for any xanthohumol on UPLC. And as we move to supercritical fluid extraction here below, so I first started with dry ground hops. I ran through with a methanolic co-solvent. The resulting extracted solution was run through a solid phase extraction column using the pass-through method. They were then filtered, of course, using a 0.22 micromolar filter and run through UPLC for identification of any xanthohumol within the samples. The microbiological side of this testing, I conducted both MIC, minimum inhibitory concentration, and zone of inhibition with a additive study of the synergism testing with gentamicin and xanthohumol. And as we move into the results, as we can see here in figure 4, from the methanolic extractions, the 100% methanolic extraction from mid-pressure resulted in the highest yield of xanthohumol at 76 micrograms per mil. However, unfortunately, the supercritical fluid extraction did not show any presence of xanthohumol. The MIC conducted can be seen in figure 6 right here on the poster. E. coli K12 did not have any inhibition from xanthohumol. However, S. aureus and B. subtilis both had inhibition from the xanthohumol dilution series, as we can see here in figure 6. I chose S. aureus as the bacteria to use in the synergism study because I was able to determine a sublethal dose, as we can see here, and bringing that over to the 96 well synergism plate. After running through the plate reader, I found that xanthohumol and gentamicin are more so additive, as higher concentrated gentamicin did not show any synergism with xanthohumol. However, as we see in table 3 here below, that as we go down in concentration of gentamicin, the wells containing gentamicin only dropped in the minimum inhibitory concentration. However, those with xanthohumol and gentamicin remained at higher MICs, as we can see here in the final dilution columns from the plate. The zone of inhibition, the synergistic plate, the synergistic disc and the xanthohumol disc both showed inhibition in S. aureus and B. subtilis. However, E. coli showed no inhibition from the xanthohumol treatments. Further studies will definitely be needed to understand the full potential of the synergistic potential of xanthohumol and to further research in its additive properties in a more pure xanthohumol sample. Thank you for attending my study.